Okay, so we're back for another session on conditional probability, and this time we're going to see how conditional probability and tree diagrams can be used together. So you've definitely seen tree diagrams before at GCSE and also in the first year of A level, but now we're going to see if we can apply what we know about set notation to what we know about tree diagrams and how to construct that tree diagram. So let's consider events A and B. If A was the event that happened first, we either have A occurring or A not occurring. So we can use A and the complement of A. Events should always go at the end of the branches, and probabilities would be on the branches themselves. After event A happens, we can either have event B occurring or event B not occurring. So we'll have B and the complement of B. We also have the same options after event A has not occurred. Now this is going to lead to 4 different outcomes: A intersection B, A intersection not B, not A intersection B, and not A intersection not B. Let's add some probabilities to the diagram first. Probabilities go on the branches. So here we have the probability of A and the probability of not A. Here's where the conditional probabilities come in. Back at GCSE, your tree diagram could have had independent events or dependent events. For independent events, the probability on both B branches would have been the same. It didn't matter what happened for event A. But we're looking at conditional probabilities. We're looking at situations where the probability of B is dependent on the probability of A. So here on this branch, we have the probability of B given A has occurred, the probability of not B given A, the probability of B given not A, and finally the probability of not B given not A. Okay, as I said before, each of these are going to lead, so let's say each of the routes that you can take through this tree diagram is going to lead to an intersection of these two events. So A intersection B we get by following the 2 top branches. So here, just looking at the generalized calculation that we have, I hope you can see just the step of rearrangement gets us back to our conditional formula. If you noticed, in that rearranging, I have swapped the order of A and B on the intersection. So the probability of B intersection A is equivalent to the probability of A intersection B. I've done that just so I have the familiar formatting of the numerator and denominator in front of me. So as I said, there are other intersections, so let's just see them all. Here we have the probability of A intersection not B, the probability of not A intersection B, and the probability of not A intersection not B. So 4 intersections that we can find from this tree diagram. I'm going to point out something here that some students don't really pick up on. Probability of A is given to us in this tree diagram, but the probability of B, well, that's not in the tree diagram. We have 2 conditional probabilities for B, but the probability that B occurs is going to need to be the combination of intersections that contain B occurring. So the probability of B is actually the intersection of A and B plus the intersection of not A and B. Those probabilities that you had calculated would be added together to give us the probability of B. Okay, let's have a look at an example. In a bag there are 6 green beads and 4 yellow beads. A bead is taken from the bag at random. The color is recorded and is not replaced. A second bead is taken from the bag and its color is recorded. Given that both balls are the same color, find the probability that they are both yellow. So we've got a standard tree diagram contextual setup, and then we've got a conditional probability to calculate. So tree diagram, and we'll put the probabilities on. Originally there were 10 beads, 6 green, 4 yellow. On the following branches there should only be 9 beads because 1 has been chosen already. If we choose the green bead, we only have 5 greens out of those 9. If we choose the green bead, we still have 4 yellows out of those 9. So let's rewind and think about our original choice again. If we pick the yellow bead, there are 9 beads in total, and I still have 6 greens. If we pick the yellow first, I have 3 yellow beads left out of those 9. Okay, we're looking at conditional probability, so I'll start with the formula as usual. I'm going to substitute the events that we're thinking of. So we're looking for the probability that they're both yellow, given that both balls are the same color. So the probability of YY given S equals the probability of YY intersection S over the probability of S. Great. Well, the probability of YY intersection S, so the probability that they're both yellow and they're both the same color, it's a bit redundant to say and the same color if I know that they were both yellow. So I'm just going to go ahead and rewrite this as the probability of yellow yellow in the numerator. Okay, let's actually try and find some probabilities now. We'll start with the denominator. So what's the reduced scope of interest? What's the narrowed scope of interest? I'm initially only interested in the outcomes where both colors are the same. The outcomes I'm interested in are yellow yellow and green green. Well, for yellow yellow, we're going to be multiplying down these branches, 4 over 10 times 3 over 9. And for green green, these branches, 6 over 10 times 5 over 9. This is the calculation in the denominator. In the numerator, I've already decided I just want yellow yellow, so it's going to be this calculation in the numerator. Okay, these can obviously be simplified, or if you'd rather just type it all into your calculator in one go, we end up with 2 over 7. Okay, so here we can see a very necessary, strong understanding of set notation, of the conditional formula, and of where these would apply to the specific branches of the tree diagram. Where is G given Y? Where is Y given G? Where is Y given Y? We should be able to pull these out of the tree diagram without too much trouble. Okay, so I'll let you get to it with some practice on conditional probability and tree diagrams. Keeping the set notation ideas in your head. Don't just revert back to GCSE techniques. There will minimally be one part of the question that you won't be able to respond to if you're not trying to pull in your A-level techniques and your understanding of them.